grab a different color here, blue. Do we know the mass of the box? Yes. Do we know G? Yes. Do we know H1? Oh, we're letting H1 be 0. So everything in that term is 0. Do we know 1/2? Yes. Spring constant? You bet. Distance the spring is compressed, 2 meters. Force of friction. Now remember, force of friction is coefficient of friction times the normal force, and we don't know the coefficient of friction, so we're going to have to draw or have to find the normal force. Do we know the distance it travels? Yeah, we know that. And we know mass, we know gravity, and we know height is 4.37 meters. So if we can just draw a little free body diagram and find that normal force, then we can solve for the coefficient of friction. So let me quick draw up a free body diagram for the box on the incline. And the forces acting on here are the weight, mg, the normal force, Fn, and the force of friction. I'm going to rotate so my x and y, instead of being the way that we like them, x parallel to the ground and y perpendicular, we're going to rotate it so that the x is parallel to the plane and the y is perpendicular. And so then if I sum the forces in the y direction equal to 0, because there's no movement in the y, in this perpendicular to the plane. Oh, by the way, if this angle is 35 degrees, then so is this angle. And we're going to say that up the incline is positive. Start with mg. Well, mg is going to be negative, and how much of it is perpendicular? That's going to be mg times the cosine of 35. The force of friction doesn't have anything in this new y, and the normal force is 100% in the new y, and this gives us our normal force. The normal force equals, put in the m, put in the g, 401.8 newtons, and now we know the normal force. So this is kind of a step 3 here, finding the normal force. And we're good now. We can use a algebra or an equation solver. Again, I like to use my TI calculator. I'm just going to type in solve. And putting things in, I don't need any of the MGH. So 1/2 K is 1459.6 newtons per meter, and 2 meters squared, so 1/2 kx squared, minus the coefficient of friction times the normal force times the number of meters, and that's 7.62, and that equals, I'm going to rotate down, the mass, which is 50 kilograms, times g, which is 9.81 meters per second squared, times h2, which we found to be 4.37 meters. And the only unknown in this equation is mu. So I'm solving this for mu. When I put this into my calculator, I don't need to do anything with the units. I don't need to put them in. and I would use a U because my calculator doesn't have a mu. Let's check our units though. Here I have newtons per meter times meter squared. That would be Newton times meter, and that's a joule. A joule, Joule. Okay, good. That is the unit of energy. Again, newtons and meters. Let's see, kilogram meter per second squared. That's a newton and a meter. All right. So we have joules and joules and joules. I get mu sub k, the coefficient of friction, to be 0.25.